In astronomy, the Earth's orbit is the motion of the Earth around the Sun, from an average distance of 149.59787 million kilometers away. A complete orbit of the Earth around the Sun occurs every 365.256363004 days. This motion gives an apparent movement of the Sun with respect to the stars at a rate of about 1 degree/day eastward, as seen from Earth. On average it takes 24 hours a solar day for Earth to complete a full rotation about its axis relative to the Sun so that the Sun returns to the meridian. The orbital speed of the Earth around the Sun averages about 30 km per second, which is fast enough to cover the planet's diameter in 7 minutes, and the distance to the Moon of 384,000 km in 4 hours. Viewed from a vantage point above the north poles of both the Sun and the Earth would appear to revolve in a counterclockwise direction about the Sun. From the same vantage point both the Earth and the Sun would appear to rotate in a counterclockwise direction about their respective axes. Distance covered in an orbit, approximating Earth's orbit around the Sun to be an ellipse with semi-modular axis of 1 or an eccentricity of 0.0167, the distance Earth travels in 1 year is 940 million kilometers. History of study. Heliocentrism is the scientific model which places the Sun at the center of the solar system. Historically, heliocentrism is opposed to geocentrism, which placed the Earth at the center. In the 16th century, Nicolaus Copernicus de Revolutionibus presented a full discussion of a heliocentric model of the universe in much the same way as Ptolemy's Almagest had presented his geocentric model in the 2nd century. This Copernican revolution resolved the issue of planetary retrograde motion by arguing that such motion was only perceived and apparent. Influence on the Earth. Because of the axial tilt of the Earth, the inclination of the Sun's trajectory in the sky varies over the course of the year. For an observer at a northern latitude, when the northern pole is tilted towards the Sun, the day lasts longer and the Sun appears higher in the sky. This results in warmer average temperatures from the increase in solar radiation reaching the surface. When the northern pole is tilted away from the Sun, the reverse is true and the climate is generally cooler. Above the Arctic Circle, an extreme case is reached where there is no daylight at all for part of the year. This variation in the climate results in the seasons. Events in the orbit. By one astronomical convention, the 4 seasons are determined by flanges, the solstices the point in the orbit of maximum axial tilt toward or away from the Sun and the equinoxes, when the direction of the tilt and the direction to the Sun are perpendicular. In the Northern Hemisphere, winter solstice occurs on about December 21, summer solstice is near June 21, spring equinox is around March 20 and autumnal equinox is about September 23. The axial tilt in the Southern Hemisphere is exactly the opposite of the direction in the Northern Hemisphere. Thus the seasonal effects in the South are reversed. In modern times, Earth's perihelion occurs around January 3, and the aphelion around July 4. The changing Earth-Sun distance results in an increase of about 6.9% in solar energy reaching the Earth at perihelion relative to aphelion. Since the Southern Hemisphere is tilted towards the Sun at about the same time that the Earth reaches the closest approach to the Sun, the Southern Hemisphere receives slightly more energy from the Sun than does the Northern over the course of a year. However, this effect is much less significant than the total energy shone due to the axial tilt, and most of the excess energy is absorbed by the higher proportion of water in the Southern Hemisphere. The Hill sphere of the Earth is about 1.5 km in radius. This is the maximum distance at which the Earth's gravitational influence is stronger than the more distant Sun and planets. Objects orbiting the Earth must be within this radius, otherwise they can become unbound by the gravitational perturbation of the Sun. Orbital characteristics. The following diagram shows the relation between the line of solstice and the line of apsides of Earth's elliptical orbit. The orbital ellipse goes through each of the 6 Earth images, which is sequentially the perihelion on anywhere from January 2 to January 5, the point of March equinox on 19, 20, or March 21, the point of June solstice on 20th or 21st June, the aphelion on anywhere from July 3 to July 5, the September equinox on 22nd or 23rd September, and the December solstice on 21st or 22nd December. Note that the diagram shows an exaggerated representation of the shape of Earth's orbit. The actual path of Earth's orbit is not as eccentric as that portrayed in the diagram. Because of the axial tilt of the Earth in its orbit, the maximum intensity of sun rays hits the Earth 23.4 degrees north of equator at the June solstice, and the maximum intensity of sun rays hits the Earth 23.4 degrees south of equator at the December solstice. Future. Mathematicians and astronomers have searched for evidence for the stability of the planetary motions, and this quest led to many mathematical developments, and several successive proofs of stability for the solar system. By most predictions, Earth's orbit will be relatively stable over long periods. In 1989, Jacques Lascar's work showed that the Earth's orbit is chaotic and that an error as small as 15 meters in measuring the initial position of the Earth today would make it impossible to predict where the Earth would be in its orbit in just over 100 million years' time. Modeling the solar system is subject to the n-body problem. The angle of the Earth's tilt is relatively stable over long periods. However, the tilt does undergo a slight, irregular motion with a main period of 18.6 years. The orientation of the Earth's axis also changes over time, precessing around in a complete circle over each 25,800-year cycle. This precession is the reason for the difference between a sidereal year and a tropical year. Both of these motions are caused by the varying attraction of the Sun and Moon on the Earth's equatorial bulge. From the perspective of the Earth, the poles also migrate a few meters across the surface. This polar motion has multiple, cyclical components, which collectively are termed quasi-periodic motion. In addition to an annual component to this motion, there is a 14-month cycle called the Chandler wobble. The rotational velocity of the Earth also varies in a phenomenon known as length of day variation. Future geoengineering projects may preserve the habitability of Earth through the Sun's life cycle by moving the Earth to keep it constantly within the habitable zone. See also, barocentric coordinates, Earth's rotation, geocentric orbit. The orbit of any object orbiting the Earth, such as the Moon or an artificial satellite, satellites, space station, notes. References. External links. Media related to Earth's orbit at Wikimedia Commons.